This question is from GATE 2018 Mechanical Engineering paper set 2, question number 49. Taylor's tool life equation is used to estimate the life of a batch of identical HSS twist drills by drilling through holes at constant feed in 20 mm thick mild steel plates. In test 1, a drill lasted 300 holes at 150 rpm, while in test 2, another drill lasted 200 holes at 300 rpm. The maximum number of holes that can be made by another drill from the above batch at 200 rpm is dash. Let's find out. We'll start by writing the given information. So, when the drill is being run at a certain rpm, the number of holes that can be drilled are given. We'll denote the number of holes with small n and rpm with capital N. So, for small n1, there were 300 holes being drilled when the drill was being run at 150 rpm. Then 200 holes were drilled when the drill was run at 300 rpm. How many holes could have been drilled when it was run at 200 rpm? That's being asked here. So numbers are all pretty jumbled up. Write the given information properly before solving this question and then refer back and put the correct information while using it. Now we can use the Taylor's law that says V into T to the power N is a constant, where T is the tool life and V is the velocity of the machine. So in this case, velocity is given in terms of RPM for the drill, and this tool life can be compared to the number of holes drilled. So definitely the higher are the number of holes drilled, longer will be the tool life, and therefore number of holes drilled will be directly proportional to the tool life. So we'll replace the tool life with the number of holes. We can write here capital N1 small n1 to the power n, where this n is the Taylor's tool life index. Don't get confused. Wherever there are subscripts, they denote the number of holes, and this n with no subscript denote the Taylor's tool life index. So we can write n1 small n1 to the power n is equal to n2 small n2 to the power n is equal to n3 small n3 to the power n. Because C here being the right hand side is a constant, and therefore we have equated all the possible equations that we can write using Taylor's law, because right hand side for all these equations will be equal to C. Now using the first two equations, we'll first find out the value of the Taylor's index, and then putting the value of n using second and third equation, you can find out the unknown number of holes in the third case. So for going for the first step, we have small n1 upon small n2 to the power n will be equal to capital N2 upon capital N1. Putting the values given, we have n1 by n2 will be 300 by 200, which is nothing but 3 by 2 to the power n is equal to 300 by 150 rpm, which is nothing but 2. So we have, taking log on both sides, n ln of 1.5 will be equal to ln of 2, taking natural log actually. So n will be equal to natural log of 2 upon natural log of 1.5. We get the Taylor's tool life index to be 1.7095. Now putting this value for this second step, we'll get n3 upon n2 to the power n is equal to n2 upon n3, multiplying the power with 1 by n on both sides. We will have n3 will be equal to n2 by n3, which is nothing but 300 by 200, which is 3 by 2 to the power 1 upon 1.7095 into small n2 is 200. So the given values are actually similar for multiple terms. Therefore, I told you in the beginning that please pay attention while substituting the values. So double checking, small n2 we have substituted correctly 200, and this is 300 as small capital N2 upon capital N3, which is 200, 3 by 2. That's correct. So this we get the answer as 253.535 holes. Actually the number of holes should have been rounded off to the lower limit, but because we have been asked to write the correct answer up to 2 decimal places, we can write it in decimal itself. Let's go back and fill in this answer. So the number of holes that can be made by another drill from the above batch, which runs at 200 rpm, is 253.535, but we can round it off to 53. So that's our answer. To learn about tool wear, tool life and the tool life equation in detail, you can refer to the NPTEL video Tool Wear and Tool Life and Tool Life Equations. It's from the course Mechanics of Machining. The course is by Professor Uday S. Dikshit. He is from Department of Mechanical Engineering of IIT Guwahati. I hope this solution will help you clear your doubt. Thank you.